This is the fourth video on Chapter 23, Systems of Linear Equations. And again, to save time and space, I did not write the system of equations. You have that in your notes. So we have the coefficient matrix, which I've called A. We have our variable vector, x. So we have four variables, x1, x2, x3, x4. And then we have our constant terms to the right of the equal sign. And so we can write our system of linear equations as a matrix and vector equation. A times x is equal to b. And if you see how that works, you have x1 plus 3x2 plus 0 plus 2x4 is equal to 1. And the same is true for the other lines. So we have ax equal to b. We are trying to solve that. And so we take the augmented matrix, AB, and we put that in reduced row echelon form. And this is the reduced row echelon form of the augmented matrix, AB. We have two pivot columns, column 1 and column 3. And then we have two free columns, column 2 and column 4. So that means we have two pivot variables, x1 and x3, and two free variables, x2 and x sub 4. We have a particular solution. Remember, the thing with our free variables is they're free to be anything. So we choose to let those variables be 0. So x sub 2 is 0, x sub 4 is 0. So we come back over here and we see what the pivot variables will be when x sub 2 and x sub 4 are 0. Right here. We see that x sub 1 will be 1, and we see that x sub 2 will be 6. I'm sorry, x sub 3 will be 6. X sub 2 and x sub 4 are 0. X sub 1 is 1. X sub 3 is equal to 6. So our particular solution, 1, 0, 6, 0. We have two special solutions. Why? Because we have two free variables. We have two free columns. Each free column gives us a vector in the null space of the matrix A. So that's what we are looking at. We are looking at vectors in the null space of A. Equivalently, we're looking for solutions to the homogeneous system as if these were zeros here. Okay, so for the second column, remember x sub 2 is a free variable. We'll let it be 1. And then we're looking for an element of the null space. So remember what we did. We have the other terms below are 0, and we go up, we see a 3, and so we have a negative 3 here. So negative 3, 1, 0, 0, this is a vector in the null space. We do the same thing with column 4. We choose, right here, we choose x sub 4 to be 1, x sub 2 to be 0, and then we look up the column. So fourth column, we look up, we see a 4 and a 2, so we have a negative 4 and a negative 2. So this is another vector in the null space. These two vectors are linearly independent. For every free column, you have a vector in the null space, and these vectors are going to be linearly independent. So now, what is the complete solution? We start with the particular solution, and then we can add multiples of elements from the null space of our matrix. In other words, the special solutions. So we have this special solution here and this special solution. So we can take any combination of this vector plus scalar multiples of these two vectors. This will be a solution to our system. And again, I've named these x sub 2 and x sub 4 to remind us that x sub 2 and x sub 4 are the free variables. You can call these anything. You can call this A and B. You can call it R and S, whatever you want to call it. But the idea is these variables range over R. They can be any real number, and any combination that looks like this will be a solution to the system. And so this particular system has infinitely many solutions.